Hey guys, welcome back to my channel. So today we're going to discuss about Karnaugh map. So coming to my introduction, I'm a second year graduating student at SVC Bangalore. My name is Sai Nandan and I belong to Aryabhatta section. So the subject we're discussing today is digital design and computer organization. And I belong to third semester, and the topic, as we discussed earlier, is Karnaugh map. So the agenda for today's presentation will be abstract introduction, purpose of using K-map, structure of K-map, types of K-map, filling of K-map, group of K-map, grouping of K-map, and disadvantages of using a K-map. Abstract. In this paper, we'll outline the use of Karnaugh map in order to simplify logical expressions. The Karnaugh, pronounced as Karnaugh map, was proposed by Max Karnaugh, a telecommunication engineer at Bell Technologies in 1953. Realization of expressions having two or three variables is what this paper aims at. Systematic way of representing and labeling a K-map is also discussed in the paper. Further, it mentions the properties of K-map which should be used while carrying out sum of min terms, that is sum of SOP, product of sum max terms of a logical expression. Introduction. As the digital system becomes more complex, the need for efficient circuit design grows. K-map allows engineers and designers to quickly identify opportunities to reduce the number of gates and components needed, ultimately leading to simpler, most cost-effective, and reliable electronic systems. In this representation, we will explore the structure and operation of K-maps, the process of grouping one to simplify expressions, and the practical applications of techniques in the digital designs. By the end, you will have a clear understanding of how K-map can enhance your ability to design efficient digital circuits. So when we are studying about K-map, we need to know what's a K-map. It's a geographical tool used in digital logic design to simplify Boolean expression. It provides a visual representation of truth tables, making it easier to identify common factors and simplify the expression. So when we have a lot of variables, a lot of Boolean expressions, to create a logical gate becomes more complex. So what Karnaugh map does is it simplifies the variables and use a simpler variable. So to design a logical expression for a small variable will be more easier way and cost effective. So here Karnaugh map plays an important role. So here you can see a Karnaugh map. I'll be discussing about how to group, how to construct a Karnaugh map, the later stage of this video. So let's continue. Purpose of using a K-map. Simplification of Boolean functions. K-map allows for systematic reduction of complex Boolean expressions by visualizing, identifying common terms, thereby minimizing the number of variables involved. Reduction of logic gates. By simplifying Boolean functions, K-map help reduce the number of gates required in the circuit. This can lead to lower cost, less power consumption, and smaller physical circuit size. Easy visualization. K-maps provide a geographical method to visualize combinations of inputs and their corresponding outputs. This helps engineers to quickly identify patterns and relationships. This may not be apparent through algebraic manipulation. Efficient grouping. K-map facilitates the grouping of adjacent cells containing ones, true outputs. This grouping process is straightforward, enabling the identification of simplified product terms that represent the logic function. The structure of K-map. K-map are typically structured as a grid. The number of rows and columns depending on the number of variables. Two variables, that is 2 into 2 grid, which has 4 cells. 3 variable K-map has 2 into 4 grid, that is 8 cells. 4 variable K-map has having 16 cells. A 5 variable K-map is having 32 cells. 6 variable K-map is having 64 cells. So we'll be discussing here till 4 variable K-map, because 5 variable K-map and 6 variable K-map are very complex. So here you can see a 2 variable K-map. So 0 and 1 represents the values which can be entered into the cells. So 2 variable K-map, as we seen before, it has 4 cells. So 1, 2, 3, 4, and we can number the cells. So 0, 1, 2, 3. So 2 variable K-map has 2 variables, that's A and B. So the possible values that can be entered in the 0 cell are 0, 0. The possible values that can be entered in the first cell is 1 and 0. So yeah, this is basically a 3 variable K-map that is having 3 variables, that is A, B and C. And so the rows represent the numbers above the rows represent the values that can be entered in the K map. So the first cell or the zeroth cell, 0, 0 and 0 can be entered, and the first cell 0, 1, 0, 0 can be entered. And similarly, this is a 4 variable K map which is having 16 cells. So 6, 4 and 4, so 16 cells. So here you can see the variables are A, B, C and D, and the values above represent the values that entered into the rows, and even the rows in front of the numbers in front of the rows represent the values that can be entered inside the cells. So here you can see 0, 0 and 0, 0. It can be entered into the 0th cell, and 0, 1, double 0 can be entered into the first cell. So this is basic introduction of K-map. So let's see how can we group the elements in a K-map in the next slide. So filling of a K-map. To fill a K-map, the output values of the Boolean functions placed in the corresponding cells. Cells are filled with 1 for min terms and 0 for max term based on the truth table. The visual representation aids in identifying patterns for simplification. So when we're studying about K-map, the main thing that we need to study is grouping of K-map. So size. Groups can be of any size, but the number of cells in a group must be of a power 1, 2, 4, 8, 16. Adjacency. Cells are considered adjacent if they share common side. In a K-map, the top and bottom rows as well as the left and the right columns are considered as adjacent. Wrapping. Cells can wrap around the edges of a K-map. For example, the top cell of a column is adjacent to the bottom cell of the same column. So here you can see with the example how can we group a K-map. So here you can see our two variable K-map, and we can group an adjacent two variables like this. This is appropriate way of grouping. So here you can see a two variable of cell 0 and 1 are grouped, adjacent cells are grouped, these two variables are grouped, and this is called tuple. So here you can see a three variable K map and three variable are grouped, but this is not possible because in K map only two variable can be grouped, 4 and 8 can be grouped. So three variable is not a proper way of grouping. So this way of grouping is not possible. So here you can see again a two variable K map and four elements are grouped, and this is appropriate way of grouping. And you can see here a group of five elements, similar elements are grouped. Five grouping is not possible, hence this is not an appropriate way of grouping. Here you can see a three variable grouping, and here you can see another situation where there is like 1 1 1, a four variable grouping is for possible here, and similarly overlapping that there is another four variable grouping is possible. So this way is possible, but here you can see already here they're grouping as a four variable is possible, but they're grouping as separate two grouping. Group is not overlapping, so this is wrong. When it is possible, we can overlap the group and make it like this, but we can't increase the size, we can't make it like three tuples because already a small thing is possible. So let's make it a simple problem and make it as simple as possible and reduce the variable size. So again, you can see here there's another example where octal is there. No, four variable is there, but we do this by paper folding technique. So when adjacent elements of the top of the K map and bottom of the K map are overlapping, so this way we can group these two elements and these two elements. This is possible, and even you can see here in the right side there's one, and in the left corner there's one. So by paper folding technique, we can even group these two, and these two make a tuple, and these two make a four grouping. So here you can see some disadvantages of using a K-map. Complexity for large expressions. As the number of variables increase, the size of the K-map grows exponentially. This can make it difficult to visualize and manipulate the map, especially for expressions with more than 5 or 6 variables. As I said earlier, there are like number of variables K-map possible. Like you can see a 5 variable, 6 variable. But when we are dealing with such kind of large K-map, large time of variables, becomes very complex, so hence is not preferred to be done. Limited to few variables. K-maps are more effective for expressions with two up to 6 variables. Beyond that, the visual representation becomes cumbersome and less practical. The same point is repeated again. A large number of variables, the more complexity is the K-map. So more variables, it's not recommended to use. Manual process. Simplification process using K-map is largely manual, requiring the user to identify and combine appropriate groups of ones. This can be time consuming and prone to errors, especially for complex expressions. Don't care conditions. While K-maps can be handled, uh, ha- K-maps can handle don't care conditions, it can sometimes be challenging to determine the optimal way to include them in group to achieve most simplified expressions. Thanks for watching my video. If you like my video, please consider subscribing my channel and thanks for watching.